Hey guys, this is your tutorial for Thursday, April 29th. Checklist items for today. We are going to work on figuring out differences between the different types of energy transfers that occur. So we're going to be looking at examples and then figuring out which type of energy is then turning into another type of energy. So that's what I'm going to go over with you today. Make sure you are working on your energy vocabulary because it is due on Tuesday, May 4th. So this is what your copy looks like. You can find it under the classwork tab. So go ahead and pull your copy out, and then I will get my copy out. So it looks like this. It says energy transformations. Your instructions say underline the 3 energy transfers that are occurring and then label that specific type of energy that is transferring. So the first one's done for you as far as the underlining goes, just so you can kind of see that you're going to be picking out 3 different types of energy in the statement. So the statement says a battery-powered alarm clock goes off and you jump out of your bed. Okay? So battery powered. We know anything with batteries is going to be chemical because batteries have a chemical reaction that occurs in them in order for it to provide power. So if your alarm clock is going off, what do you hear when your alarm clock goes off? What does it make? It turns into a sound, right? So that chemical energy then turns into sound energy. Those batteries make your alarm clock make a noise. And then you jump out of your bed. So you're laying in your bed, you get out of your bed, the total motion of you, the object, would be mechanical energy. So this is essentially what you're doing. You're picking out the 3 parts of an energy transfer and then figuring out which type of energy is going and turning into the next type of energy. Okay? So statement number 2 is not underlined for us. We have to figure it out. It says a battery is placed in a flashlight, which completes a circuit and then produces light. So your first keyword here is a battery, right? If a battery is placed in a flashlight, we know that's our first type of energy. So there's battery. Okay, it completes a circuit. So when you think of a circuit, you should think of like electricity flowing. And then it produces light. And we know we even have a specific type of energy that goes with light, and that's light energy or radiant energy. So those would be the 3 things we would underline here. Well, we just said in the first statement that a battery is a chemical reaction, right? So there's a chemical reaction that takes place for that battery to power whatever is occurring. So we have our battery is put in the flashlight. It completes a circuit, an electrical circuit, right? So that's electrical. And then that produces light when it's turned on. So you can put light or radiant energy. It's okay. It means the same thing. So there's how you do number 2. I went through and plugged in all the mechanical answers for you guys just because I feel like mechanical energy is kind of harder to figure out because it's the total motion of the object. So I went ahead and plugged them in so that we could just roll from there. So number 3 says a rotating turbine generates electricity to power a blow dryer. So we have a rotating turbine, right? If it's rotating, it's moving. So it's completing a bunch of energy. That's the whole energy of the turbine. It generates electricity. That's what gives it its electrical power. And then that power is then used to turn on a blow dryer. So we have a rotating turbine as mechanical energy. If it's generating electricity, that means it turns into electrical energy. And then if the blow dryer turns on, think about what you use a blow dryer for. It's for heat, right? So it's going to create thermal or heat energy. So there's your answers for number 3. Mechanical, electrical, and thermal. Number 4 says a lion on a cliff's edge pounces onto a deer below and consumes it, which means he eats it, right? So if you have a lion on the cliff's edge, he's about to move, but he hasn't moved yet. So we know it's stored energy. It's some type of potential energy. There are different types of potential energy. You can have gravitational potential energy where the gravity pulls you down. Or you have elastic potential energy, which is like the stretchy kind, like you're like a spring. So in this situation, you're right on the edge of a cliff. You could fall down. Gravity could pull you down. That's definitely going to be gravitational. And I'm just going to put PE for potential energy. It then goes down and pounces. So it was sitting still. Then it moved. Total energy is mechanical. And then it consumes the deer, or it eats it. Anytime we eat, we even learn this with our digestive system, there are chemical reactions taking place in your stomach with the acid breaking the food down. So that is definitely chemical energy. Number 5, a person is standing on the edge of a diving board. So we're already starting off just like the lion, on the edge. So he's standing at the edge of the diving board. He then pushes down to compress it and then bounces up. Okay, so if he's on the edge, that's gravitational potential energy. So gravitational PE. But now he's getting ready to go, so he pushes down really hard on that board. So it's kind of like a spring kind of situation, right? So then it turns into elastic potential energy, and then it's mechanical. So let's make sure we are underlining our stuff, because I didn't do it on the last one. So on the edge of a diving board, compresses the board, and then bounces up would be the things you'd underline there. And for the lion one, it's on the edge of the cliff. It then pounces onto the deer and consumes it. Okay, so here are your answers for the first page. For the second page, we have atoms fuse in the sun to produce sunlight that's absorbed by plants. Anytime you have atoms fusing, that's going to be like a nuclear reaction. That's like one of the very few times we see an example of nuclear energy. So we're starting out with nuclear energy. Okay, so we're going to type in nuclear. It fuses in the sun to produce sunlight. So if it's producing sunlight, it's making light energy or radiant energy. And then that is absorbed by the plants. Well, we know the only way plants can use sunlight is through photosynthesis, and that is a chemical reaction. So there are your answers for number 7. Number 8 says coal, which is a fossil fuel, is burned to generate electricity. Well, when you have coal, let's underline coal. Since we know it's a fossil fuel, we know some type of chemical reaction is going to happen. It gets burned. When something is heated up or burnt, that's thermal energy. And then it produces electricity, which is electrical energy. So I'm going to go ahead and fill this in as I go. So we have thermal and we have chemical, because all of your fossil fuels will be examples of chemical energy, because a chemical reaction occurs to turn them into something else. Number 9, a rubber bike horn is squeezed. So it's sitting still, then it gets squeezed, total energy, that's mechanical. It compresses it down and produces a honking noise. So we have, yes, it's squeezed. Then it's also compressed. And I didn't highlight that. See, that's going to annoy me. There we go. And then it makes a honking noise. So the noise is the other type of energy. So we start with mechanical. A compression or a squeeze would be like elastic, right? Elastic PE, potential energy. And then the noise that it makes is sound energy. So there are your answers for number 9. Number 10 says a glass sitting on the edge. So once again, we have something on the edge that gravity can pull down. So we're going to start with gravitational potential energy. It then falls. So it was on the edge, then it falls. Total energy is mechanical. And then it makes a loud breaking noise. So this one's easy. We're just going to highlight edge. We're going to highlight it that it falls. And then we're going to highlight noise, because it leads to a loud breaking noise. So once again, gravitational, PE, turned into mechanical, turned into sound energy. Number 11, we got another fossil fuel here. We got propane, which is a fuel is burned, and then that causes the hot air balloon to lift up off the ground. So here we go. We're starting out with propane, which we know is a fossil fuel. So there's a chemical reaction that's going to take place. So we're starting with chemical. Okay. It's burned, which is turning into thermal energy or heat energy. And then it causes the hot air balloon to lift off the ground, which means it moves. That's the total energy of the object. It's mechanical. And the last one, a charger powers a phone that chimes when it's turned on. So what do we know if you're charging your phone? I'm just going to highlight charger here. In order for your charger to charge your phone, it has to be plugged in. So you're starting with electricity, so electrical energy. It then powers the phone. So it wasn't working, now it is working. Total energy of the object is mechanical. And then when it gets turned on, it chimes, which means it's going to be making a sound. So it turns into sound energy. So here are all your answers for the second page. Okay, if this did not make any sense to you whatsoever and you are still confused, please reach out to us so we can help you out, okay? Thanks.